Welcome everyone to this video. Uh, we are going to discuss a question in this one. Uh, the question pertains to the idea of atomic collisions. So, how do we deal with atomic collisions? In collisions, normally we talk about elastic collisions and inelastic collisions. There is some loss of energy in case of inelastic collisions, and in elastic collision in a elastic collision, there is no loss. So, in case of atomic collision, if the lost energy has the probability to get absorbed into some transition, then we'll say it could be an inelastic collision. If there is no probability of the possible loss of energy to get absorbed in any kind of transition, then it has to be an elastic collision. Now, let us begin that in this question we have a helium ion which is in ground state and it is going to collide with a proton or a neutron, sorry. Uh, let's see what will happen if it is given that the kinetic energy of the proton of the neutron is k. So this proton is going to collide head on with this helium atom. The question is, find the minimum value of k so that there can be a perfectly inelastic collision between these two particles. So for a perfectly inelastic collision, if this is a proton and this is a helium atom, uh, again I have named this proton, this is a neutron. So this is a neutron and this is a helium atom. Uh, Basically, this k is the kinetic energy of this proton. Now, when it is going to strike this helium atom, what will happen finally? If it has to be a perfectly inelastic collision, the helium atom and the neutron they will move together with some common velocity, which we know as velocity of center of mass. So, the crux of the question is the energy lost in coming from this state to this state has to be equal to the transition energy of this helium atom. The, the neutron is not going to get transition into one of the orbits. Instead, whatever energy the neutron is going to provide, that is going to be absorbed by this helium ion, and the electron is going to transition from the ground state to an excited state. And for kinetic energy to be minimum, that excited state can be n equal to 2 only, right? It is given energy in nth orbit is minus 13.6 z square by n square. So energy loss maximum possible is equal to half of the reduced mass into relative velocity. So this has to be equal to this loss in kinetic energy has to be equal to transition energy, that is 13.6 into 2 square m into 4m m1 into m2 upon m1 plus m2 into relative velocity v squared is equal to. So this value of k equal to 51 eV. This is the minimum possible value of kinetic energy for which uh, we can have a perfectly inelastic collision between these two species, that is the neutron and the helium atom. So pretty interesting idea. Thank you for joining and have a good day.